Okay, Assalamualaikum. Hi guys, this is atomic structure for the first topic. So, at the end of this topic, we should be able to describe the Bohr's atomic model and then explain the existence of electron energy levels of electron in an atom. To calculate the energy of electron at certain energy level by using this equation, and then calculate the energy change, which is delta E, wavelength, and frequency of an electron during transition. So what's meant by transition? So we are going to look through this lecture. So this is Niels Bohr, right? So he said that I pictured the electron orbiting the nucleus much like planets orbiting the sun, right? However, electrons are found in specific circular paths around the nucleus and can jump from one level to another. So, you will need to know on how to describe Bohr postulate. So, Bohr said that electron moves in a circular orbit or certain radii with specific energy around the nucleus. So that's mean electron is feeling attraction from the nucleus because the nucleus has a positive charge, electron has a negative charge, so it will feel that energy means is the attraction energy, right? So electron moves in a circular orbit or certain radii with specific energy around the nucleus. So as we know, right, these circular orbits, wherever the electron is, for example, this electron is in n energy level n equal to 1. So wherever the position of that electron at any time, since it is moving in a circular orbit, that means it's going to have the same distance, right? The same distance from the nucleus. Therefore, its energy is fixed, or it has a specific energy, right? Because it moves in a circular orbit. As we know, circle have the same radius. Okay, have the same radius. The circle have the same radius. So wherever the position of the electron at any time, okay, it will as long as it is in the same shell or in the same energy level, okay, it will have the same energy. Okay, despite of its position. So in moving the circle, the electron does not radiate any energy and does not absorb any energy. So second postulate says, in the specific energy level, the energy of an electron is fixed in value or is quantized, right? So quantized means electron moving in an orbit can have only a certain fixed or specific or definite amount of energy. All means the same meaning. Okay, all have the same meanings. That means, as I said earlier, okay, if this electron is in the energy level n equal to 1, okay, is at energy level n equal to 1, so it will have the quantized. We can calculate its energy, right? Yes, we can calculate its energy. So the energy of an electron in its level is given by En equal to negative RH 1 over n square. Here where RH is the Rydberg constant, so you don't have to memorize. You just look at the constant given in front of your exam paper. Meanwhile, n is the principal quantum number starting from 1, 2, 3 until infinity. Right, so this is the formula. Let's say, okay, you want to calculate the energy of electron at energy level 1. Right, so En, first write the equation En RH1 n square, where n is the principal quantum number. So let's say it is at E1 negative 2.18 10 to the power of negative 18 joule times 1 over 1 square. Okay, so since 1 square equal to 1, so that means its energy is equal to, it's going to have the same value as the Rydberg constant. Right, this is the energy of electron at principal quantum number n equal to 1. So if you calculate when the energy of electron when it is at principal quantum number or n equal to 3, so we'll find out that its energy will decrease, right? Its energy will be less than this. Why? Because as we know, it experiences attraction, right? The electron experiences attraction from the nucleus. So the further it is located from the nucleus, therefore it will have the lower energy. Okay, so if you want to calculate the energy of electron at its level, so please use this equation. So the third postulate says that at ordinary conditions, the electron is at the ground state. Ground state means lowest energy level. So if energy is supplied, electrons absorb the energy and is promoted from a lower energy level to a higher one. That means electron is excited. So let's see, okay, initially electron, okay, is at n equal to 1, which is at its ground state, for example, and then when energy is supplied, it absorbs enough energy and move up to n equal to 3, right? So at this point, this electron is excited. But electron at excited states is unstable. It will fall back to lower energy level and release a specific amount of energy in the form of light or photon. Right? So the light emitted will have a specific wavelength. Thus, a line spectrum is produced. The energy of the photon equals to the energy difference between the level. So this electron just now, it is at the excited state n equal to 3, so it will fall back to its ground state, releasing energy in the form of releasing energy in the form of light, in the form of photon. Okay, so when electron is excited, it absorbs energy. So energy change or delta E must be positive because absorb energy. But when electron drops from a higher level to lower energy level, energy is released. So it's going to have a negative value. Okay, so we can prove it by using equation. Of course, we can calculate this because since energy in each level is quantized. So this is the example of energy level diagram. So energy level diagram. So you must first label the y-axis as energy, okay, and then you must draw the energy level. So please take a look here. The distance between the energy level, as the principal quantum number increases, the distance between the energy level decreases, right? So it must decrease. So as you can see, from n equal to 1 to n equal to 2, the gap is big and then getting smaller. You must do this. Okay, so in the exam paper, okay, it is you will be given a kertas yang bergaris-garis kan. Jadi you akan confuse lah. Takut you garis je sama lebar, tak boleh. Okay, dia kena lebar yang semakin lama semakin kecil. So you must try to adjust lah. So as we can see, n equal to 1, n equal to 2, n equal to 3, 4 until infinity. This is what we call continuum limit. Okay, di mana dia garis-garis dia, energy level dia dah bercantum. Okay, so when, for example, by using the same example like just now, okay, so initially the electron is at its ground state where it is from n equal to 1 ground state, okay, and then it absorbs enough energy, move up to higher energy level. So here we say energy is absorbed, so the value of delta E must be positive, and then at the excited state it becomes unstable. So it fall back to the ground state. It must fall back to the ground state because when it absorbs certain energy, it will release the same amount of energy, right? Okay, so it will have a negative sign. When you calculate the energy release, you will have a negative value of energy. There are a few points to remember. Okay, you must remember or memorize the word ground state. Ground state means the most stable and the lowest energy state of an atom. So ground state not necessarily be one. Okay, so in the next lecture we are going to learn that okay the ground state of an electron depends on the emission spectrum. Okay, so it could be n equal to 1, n equal to 2, 3, 4, 5. Okay, so excited state means the state which is higher than ground state. So let's say the ground state is n equal to 1, so excited state must be 2, 3, 4, 5 up till infinity. Any value, any energy level as long as it is higher than the ground state. Let's say the ground state is equal to 2, so the excited must be from 3, 4, 5 and so on. Okay, in which the electron have shifted from a lower energy level to a higher energy level. Meanwhile, energy level means energy associated with a specific orbit or state.